Professor Kim, Dean of the College of Engineering, Professor Dong Bin-min, ladies and ladies and ladies and few gentlemen. It is my great pleasure to be here, and I'm a strong believer in the segregation of the university students. Although in Taiwan, most of the university is now co-educational, but I still believe the importance of women's university. One reason was 20 years ago, when I was in France, I saw many female scientists in France. I didn't find it in England or Germany or the States, so I keep on asking the question, how come you have so many women scientists in France? Is that because of the Madame Curie? He said, no. Madame Curie is because of France. And then I asked the question, why? Somebody said, because in France, it's easier to find some aide, assistant, or a nurse to take care of children, but many people say no. One of the reasons was that the higher education was segregated in France for quite a long time. So when you're in elementary school, when you reach the 6th grade, women are stronger than boys. Girls are stronger than boys. That I can fully understand. My wife was my classmate. She was bigger, she's stronger, very dominant at the time. I didn't fall in love with her at the age of 7 or 8 or 10. But anyway, by the time you develop into high school, especially in the late stage of high school, the development of male is really more advanced, so male tries to dominate. So when you put student or female and male together in the university, male always try to dominate. And it's not bad, it's not good for female students. But then later on, when you graduate in the graduate school, then it will other way around. Female become stronger. So we believe the reason there are so many female scientists in France was because of the segregation of higher education. I do believe so, because one of my friends, Professor Bernstein, is a daughter. When she was attending the University of Texas in Austin, she was a very timid person. Then Professor Bernstein went to Columbia University, and her daughter transferred to Barnard College. In the second year, she changed completely in the women's college. She became very assertive, very strong. So I did see the big transformation. So Professor Bernstein also said, yes, it is important to have a women's university, but this is one of the greatest women's university. So I'm really very pleased to be here. I think many of you, as a student, when you enter the university, many of the professors might try to tell you, world is different now. One thing is, you see the globalization, you also see the democratization and diversification. At the same time, people convince you that the science and technology is now driving the development of the human society. Of course, once you enter the university, and you might start to ask which are the most important area of science or technology. People always say bio, nano, informatics. And of course, if you look at what has been developed during the last 10, 20 years in the biotechnology or nanosciences and informatics, it was really amazing. But then people tell you, actually, very important thing is environmental. And that's the issue we are facing today And that will be the issue which will determine whether we will be able to survive, human society will survive into the next century. This is really important question. Of course, when we are talking about environmental, just like many other issues, become very complicated. And so people always said you have to learn to be cross-disciplinary, interdisciplinary. You really have to try to solve the problem from different perspectives. Today, I'm going to talk about challenges for scientists and engineers for the 21st century. As I said, we are really facing very great difficulties. And if we could not overcome the problem we are facing, we might not survive beyond 21st century. I'm not threatening all of you, but I come to the age I know that we will be passing over our Earth to the younger generation, and I feel tremendous responsibility about what kind of Earth, what kind of human society we are heading over. Well, after the Big Bang, it took more than 9.5 billion years before the Earth system was created. And after the solar system was created, it has been about 9.5 billion years already. It has been a long time. But because the Earth is located in a very special location, so after about 1 billion years, phenomena of life started on the surface of the Earth. And photosynthesis, sun start to recycle many things through biomaterial on Earth, and human society developed. But if you think of it, actually it was the sun which brought us here. You turn off the sun, everything will be deteriorated in a relatively short time. So that's the origin of everything we have today. Sunshine, very powerful sunshine. And this is after about 4.5 billion years after the birth of the solar system. If you look at the Earth today, it is quite interesting. Our ancestor appeared on the surface of the Earth maybe a couple million years ago. And throughout the history, the development and evolution of mankind on Earth certainly will have a strong interaction with the environment. But because the number of humanity is so small, the impact of human activity to the Earth system is quite negligible until about 300 years ago. Although about 10,000 years ago, when agriculture started in many parts of the world, locally, I think human activity did destroy some environment, but as a whole, still was quite negligible. But 300 years ago, things started to change. If you see the picture here, this is on the left-hand side, you saw the painting done by a famous painter 300 years ago in Taiwan. That was the livelihood of Aboriginal tribe in Taiwan. It's the wedding ceremony. And I think they are quite equal. Both husband and wife are carried by somebody, not by carry only the bride or bridegroom. They are sitting together. But this painting, what I want to say is, if you look at the housing, clothing, what they eat, what they wear, all came from biomaterial, really created by sun, and sun has been recycling matters on the surface of the Earth. But after Industrial Revolution, things has changed. We start to dig things out from underneath the Earth and then transform it into steel and cement So we started to dissociate ourselves from the sun and departure of us, dissociate ourselves from the nature. And that is really a quite important turning point for the history of mankind. And we started to believe that we are the master of the earth, master of the universe. And after the Industrial Revolution, if you look at the energy consumption, really increased tremendously. This is 1820. By 1900, green part is biomass, burning of the wood. Then coal burning started to become important and consume more and more coal. And starting from 1900, we started to burn oil. And then natural gas. So by the end of the 20th century, energy consumption went up, and most of the energy are the fossil fuels: coal, oil, natural gas, and hydro power generation is not really that important compared to the coal burning, and nuclear is still play relatively small role. So that increase of energy consumption also changed the nature of the energy we are using from sunshine to the fossil fuel that was accumulated on the surface of on Earth for millions of years. I'm a chemist. I do work on the chemical dynamics, and I spend a large fraction of my life trying to understand the combustion of hydrocarbon into carbon dioxide and water. And what I'm saying is really this chemistry. Hydrocarbon, carbon and hydrogen, actually in the coal, carbon to hydrogen ratio is 1:1. Petroleum is carbon hydrogen ratio is 1:2. And methane, natural gas, is 1:4. But you burn it or produce carbon dioxide and water. And we keep on saying that the combustion is important, provided 85% of the energy we use. But along with the energy consumption and advancement of science and technology, our living environment improved. And we invented vaccine and invented flush toilet, refrigerator, and so on and so forth. And what happened was the population explosion. It was really amazing to see. The number of people went up. This is 2000 BC to 0, and in 2000 years, and especially during the last 100 years, population really went up. And at the beginning of 2000, no, actually 1900, population is only 1.5 billion people. End of the century, end of 20th century, went up to 6 billion. Today, we exceeded 7.2 billion, and United Nations is forecasting the population will go up to 9.5 billion in 2050. That will be another 30% more people on Earth. And in 1950, many scientists believed that the Earth can support about 2.5 billion comfortably. But as population goes up and up, non-renewable resource depletion becomes serious, and when population goes even higher, as unsustainable growth rate, many parts will see the starvation, and then worldwide environmental damage will occur. And when population goes up, and it's interesting, we are predicting that we will have 9.5 billion people on Earth by 2050. That's a lot of people, already exceeding the period when 1950 said Earth can support about 2.5 billion comfortably. 20 years ago, about 50 academies all over the world. They got together and made an announcement that the population explosion should be controlled. Otherwise, many of the problems we are facing today will not be solved. And in the Rio Plus 20, 2 years ago, just before Rio Plus 20 meeting, 100 academies also got together and wrote suggestion and said, we really need to control the population, otherwise problem is not likely to be solved. But we are not doing that yet. Although places like Korea, Japan, Taiwan, population is going down, probably going down. In Taiwan it's the worst, and you go down to replacement rate of 0.9, going down rather quickly. So many governments in Europe is trying to encourage to have young people to get married, produce more children. So they cannot turn around and tell the people in India or Africa and say control the population, because what they are doing and what we should do is just in the opposite direction. And because of the population increase so much, and per capita consumption also increased immensely. During the last 100 years, per capita consumption increased more than a factor 2. So population went up by factor 4, per capita consumption by going up by factor 2. So before the end of the last century, compared to the beginning of the last century, we are loading the earth by 8 times. 8 times. But as you know, sunshine has been recycling all the materials, try to restore what we have done through the human activity, but that capacity have exceeded during the last 50 years. And that was something I tried to say, that the people like Professor Min, he's still a lot younger than I, but it's not that young anymore. So when we look at what we have done during the last 50 years and what you are going to be facing, the problem is really quite serious. So additionally, this artwork was done by Andrew Young, sitting there. Sitting behind is my assistant who drew this picture. He's a good artist. So now, if you look at the spectacular growth of human impact on the planet, it's really quite interesting. No matter what you look at, like atmospheric carbon dioxide concentration goes up, the line, red line, is 1900. So during the last 100 years, you look at the carbon dioxide, N2O, or methane. This is quite a bad global warming gas. And if you look at the ozone depletion, or temperature rise, or great flood, ocean ecosystem, coastal zone structure, all deteriorating quite seriously, and global biodiversity also. So during the last 100 years, especially during the last 50 years, we started to overload the earth. Human society overloaded the earth. So Johann Ropstrom keep on talking about the boundary, and he came to the conclusion some time ago, the earth is overloaded, and we already passed through the safe green area, and climate change, biodiversity loss, or nitrogen cycle. You look at every aspect, we are really moving toward certain problems. But out of those problems, what we are going to face almost immediately, I'm talking about next 5, 10, 20 years, is the global warming. It's the global warming. Why I'm talking about global warming? And why it's going to hit us very, very quickly is, as I said, we are overloading Earth. So if you look at the ability of sun to recycle the material on the surface of the Earth, we are now consuming 1.5 times more than what sun can restore. So forest is disappearing, rainforest is still disappearing. If you look at the ocean, not only the acidification over harvesting, fish species is declining. And so if we said we are consuming 1.5 times of what sun can recycle or create for us, we know that we are sinking quite quickly, sinking rather deep quickly, and it will be taking no time before we are going to face serious problem. Why I said global warming is more important? This is a picture taken by a satellite long way away. Sun is just behind us. And you are seeing the very thin layer that is the atmosphere, or including biosphere, hydrosphere. That's the thin layer we live. We human society live on that very thin layer altogether, including all the atmosphere, maybe up to 50 kilometers. And actually, the important part is less than 10 kilometers. Sunshine brought us here, and sunshine will not only recycle the material, human society develop, and all the activity, what we are doing, depend on these thin layers. And if you look at the energy balance on the surface of the Earth, now you look at the surface of the Earth, move the sun far away. That's the picture of the energy balance. Sun, the temperature is very high, about 5,000 degrees C, emit the visible light, and some of them are UV. Infrared light is relatively not as much as the visible. And the sun will irradiate the Earth, and some of the sunlight will be reflected by the cloud, and some will be absorbed by the atmosphere. Major part will be absorbed by the surface. And that amount altogether will be about 340 watt per square millimeter, per square meters coming down to the surface of the Earth. And that amount is irradiated back to the universe. But Earth is relatively cool, maybe 25 degrees centigrade on the average. The light emitted from the surface of the Earth is infrared. You cannot see it. In the nighttime, it's pitch black, you cannot see it. But if I have an instrument which is sensitive to the infrared, then I can certainly see every one of you very clearly. Well, that infrared light will be absorbed by so-called greenhouse gases like carbon dioxide, methane, fluorocarbon. So as the greenhouse gases become more concentrated, the energy, because will be absorbed, it will not as easy to dissipate the energy. Some of the energy will be radiated back, some will be radiated back to the universe. So as the concentration goes up, the surface temperature will go up to keep the balance of incoming energy and outgoing energy. Without greenhouse gases, the average surface temperature of Earth would be maybe minus 15 degrees centigrade. Maybe the coldest winter in Seoul will be about average temperature. Because of the greenhouse gases, Earth is relatively warm. But if the greenhouse gases become more and more concentrated, temperature certainly will go up, and that is what's happening. It's what's happening now, and the rate the temperature is going up, or the rate greenhouse gases is increasing. It's really worrisome. Let's look at the next picture. Well, you do see the oscillation. That is the season. Summertime, because of this photosynthesis is more effective, so concentration will be go down. Winter goes up, so all the 4 seasons, up and down, up and down. The blue part is the South Pole. Winter and summer is just opposite, and the oscillation is not as serious. But what you do see is from 1980 going up and up and up and up, and now we are shooting up to about 400 parts per million. This is 400 parts per million. So if you trace back from 1960 up, you do see that the human activity really produced so much carbon dioxide, it is going up. Now, if you trace back the history, that is a pre-industrial level of 278 parts per million. And if you trace the time further and further back, then you go through the ice age and go to the warm period, go through another ice age, go to warm period, ice age, warm period, and these cycles, and about 10,000 years go through the cycle. The reason is the orbit of the Earth surrounding the Sun is not circular, and also the axis of the rotation of the Earth itself, and make an angle with the orbit of this Earth around the Sun. So that's the period of oscillations. And people always said, Professor Lee, why you worry? You wait for a while, it will cool down. But how long are you going to wait? Could you wait for a couple thousand years before Earth to go down, as temperatures to go down? Besides, if you look at the cycle, we are at the warmest period. And so when we said carbon dioxide is going up, up, and we are now really very, very high. If you look at the historical perspective, reaching about 400 parts per million. And scientists will tell you that if the carbon dioxide concentration will go up to 450 ppm, then average temperature might go up 2 degrees centigrade. That will be a dangerous temperature. Well, as I was saying, that we are just passing through the ice age. The Earth is the warmest time, and then carbon dioxide keep on going up. So we cannot wait. It can only take a couple thousand years before it will really go down. So I said, scientists will tell you 450 parts per million probably will be the maximum amount of carbon dioxide we could have. But if you look at the amount of carbon dioxide we are putting into the air, and the amount of concentration goes up, it's about going up at the rate of 2 parts per million. 2 parts per million. From 400 to 450, only 50 parts per million to go. And if you divide by 2 parts per million, 25 years. Well, 25 years, I will not be here. But I should not say all, but most of you will be here. The sad thing is, politicians only look for the next 4 years, at most, next 4 years. I did represent economy and attend the APEC meeting some years ago, and all the people talk about next election, all the president worry about the next election, worry about the next 4 years. But this is 25 years. I'm talking about 25 years. 25 years is something young people should really worry about, but politicians usually will not pay as much attention. I have many good friends who are wonderful person, and he always tell me, after I told him something I'm worrying about, he said, Professor Lee, it might be too late. I said, no, it's not too late. If we work on it, if in the next 10 years we turn things around, we still are very hopeful. Then he said, Ian, well, you will not be here at that time. And that's something I think we should not allow them to say. I think they will not be here. I will not be here, but you, most of you, will be here. So, this is where we are. This is where we are. And then, if we work very hard to bend the curve, then maybe will the temperature of the Earth go up to 2 degrees centigrade from pre-industrial era. So that is something why we are talking about 2 degrees. 2 degrees is already very dangerous. If we do not do anything, if business as usual, as we are doing at the present time, the temperature will go up to 4 or 5 degrees centigrade. Then I do not believe that humanity will be able to survive. But that argument of 2 degrees and 4 degrees centigrade was not a good argument put forward by scientists. One of the reasons is when you wake up in the morning, -5 degrees, by lunchtime, maybe 0 degrees, and if you look at the season, from -20 degrees could go up to +30 degrees, 50 degrees. And lots of people said, why scientists are so stingy? Always talk about 2 degrees. And last year, we broke the record. Not last year, this summer, this past summer, many places, actually the entire world, is reached the highest temperature. Nobody feels very much about it. Why? Because you come to the room, you turn on the air conditioner. You go into the car, turn on the air conditioner. Outside is 37, inside is cool, 25, 26 degrees, so you don't feel it. But if one of the days, power were to shut down, electricity will not come, then 35, 36 degrees, many of the people, many, especially the older one, will pass away. I do remember when the heat wave hit Paris, I was attending the meeting. 35 degrees centigrade lasted for almost a week, and 2,000 people died. Most of them are elderly people. I was talking about temperature, but as I said, that's really not reflecting the importance or the reality. The reality is, when temperature rises, in the thin layers, water will be evaporated more, contain more energy, and extreme weather events will be very unbearable. So let's look at what I'm talking about. IPCC keep on saying that we should try very hard to keep the temperature to 2 degrees centigrade, because if you go up, it's really going to be problematic. In this chart, this is usually known as a burning amber, published by IPCC this year. If you look at the white color, there's no problem. Then when color becomes orange, then you are facing some problem. Become red, it will be serious. Become purple, it's really unbearable. So if you look at this, unique and threatened systems, this is pre-industrial era, used as a 0 degree, then we are up to 0.6 degree higher. Or if you use the current temperature 0, this is minus 6.1, 0.61 in the pre-industrial era. the color from white move into orange. It means unique and threatened system is now pretty bad. And extreme weather events at the present time become more and more serious. That probably you are experiencing, or the people around the world are experiencing. But one thing, that is large-scale singular events, it means suddenly something happened, and drastic change, and we might be just like dinosaur, disappear from the surface of the earth. Pre-industrial era, that possibility is not there. But when the temperature starts rising, and when we talk about 2 degrees centigrade from pre-industrial era, if you look at the color, it's really miserable. So we said we will maintain at 2 degrees centigrade. It means we will be pretty miserable at that time, but still could survive. If you let the temperature keep going up, going up to 4 degrees centigrade, there's no chance we'll be able to survive. So I would like to look at the extreme weather events and try to tell you what's going on at the present time. If you look at the extreme weather events, just look at the flood. This is the major floods per decade. Again, the data accumulated by IPCC. From 1950, every 10 years, you look at the flood, it's really increasing. It means when the temperatures goes up, drought and flood become more serious. And when it rain in a very short period of time, brought down lots of rain, or you don't have rain. So this year, if you were to be in the United States, you see California is in drought. New York last week, it's a big snowstorm. Now, in Taiwan, we're running out of water. In Japan, last summer, whenever I receive an email from Japanese scientists last summer, always said, this is the hottest summer, most miserable, every typhoon hit Japan instead of hitting Taiwan. It's avoided Taiwan and always hit Japan last time. So you look at this, you see every 10 years going up to 2000, America, Europe, Asia, and if you plot the drought will be similar way. Drought is going up. Africa is the same, except one place called Oceania, Australia, and New Zealand, Papua New Guinea area. It's now going up and down again. So when this picture was made, many Australian scientists tried to convince me, said, Professor Lee, I told you you should immigrate to Australia, and if you have a nuclear holocaust, the bomb will be thrown from US to Russia, or it will not, nuclear bomb will not thrown to Australia. So he said, I told you, you should move to Australia. It's a different place in the southern hemisphere. But look at what happened. After 6 months, he tried to convince me to move to Australia. They have a major flood, and that flood covered the area of France and Germany combined. And this is something, a disaster of biblical proportions. It means it will only happen 1,000 years in a time. Anyway, no place could avoid this extreme weather event. And if we continue on to let the temperature go up to 4 degrees centigrade, it will be serious. So let me show you a couple slides. If you look at the next slide, that was in Taiwan. Morocco typhoon went through 5 years ago. And there is the picture before typhoon moved in and out. In 2 days, they dropped 2 meters of rain. 2 meters in 2 days. 2 meters really not like this. I'm 177, 2 meters, about that much water, drop in 2 days. If you were to be in the middle, you will see that there's somebody upstairs forgot to turn on the faucet. Water just keep on pouring down. In 2 days, that village disappeared. Landslide, and about 700 people killed overnight. Prime Minister was forced to step down. And let's look at the next slide. I think you must be familiar with what you have seen here. And this is Typhoon. Filipino people say Yolanda, Typhoon Yolanda, and in globally called Haiyan typhoon. The typhoon landed with a speed of 300 kilometers per hour. That's the highest speed human society ever experienced. And 7,000-8,000 people killed almost instantaneously when typhoon swept across. Lots of people could not be found. So this is really quite serious. I think typhoon, a smaller one, is hitting Philippines yesterday, and I think it will be quite serious, probably not as bad as this one. Also, the second thing which is important is biodiversity is disappearing, and we really do not thank enough for many little things like bees. They are pollinating the flowers, and 1/3 of the food we eat is pollinated by wild insects that produce over 200 billions. And when the climate changes, biodiversity loss, nobody can do it for us. We have to do it, pollination ourselves. And that would be ridiculous, but it's already happening. A couple of years ago in China, one of the villages which are producing pears and lots of flowers, Iwa, because bee disappeared. They asked government help. Government said, "Hi, how can I help? You better do it yourself." So there's a TV showing farmers using leather, climb up the trees and flower using feather to do pollination. It looks like ridiculous things. Something little insect will do it for you free. Now you have to see 5 kilograms person climb up the ladder to do pollinations. And likewise, I think coral supporting lots of livelihood are now whitening because of the global warming, acidification of ocean. So that will be going on and on. But the important thing is the future of humanity is at risk. So that's the biggest challenge we are facing for scientists, engineers, our survival. So it's not like we are talking about bio, nano, informatic, environmental as if it's one of the 4 things. But what we are facing today is really our survival. It's really not just one of the disciplines of science we have to learn. If we do not do something to slow it down, we will not survive. And that is some of the things politicians do not like to tell you, or many people do not like to face. So as I said, we are overloading the earth. If we think of it, then we say we have to develop. Or when we say sustainable development, then one of the questions we ask, what do you mean development? If we are overdeveloped, not the US and Europe are overdeveloped, Korea, Taiwan are all overdeveloped. China also is overdeveloped. They didn't want to confess it. If the entire world is overdeveloped and there's no reason for the people in overdeveloped countries come to tell you how we should develop. It is interesting. Whenever in the international gathering, when I said we are overdeveloped, then the people from the West, in America and in Europe, said, wait a minute, Professor Lee, we can make it sustainable. We can make it sustainable. And we'll move into not overdeveloped, but we'll have enough energy. But the people in Africa would say that Professor Lee, don't say our human society is overdeveloped, because Africans are miserable. We need to develop. And they will say something further and say, if we have to die, we will be dying together. That's what he said. I said, no, we should not moving into destruction. We could work together and find a different way of development. If the entire world is overdeveloped, and overdeveloped country will not the flagship anymore, we have to find a different way to develop. We can use small amount of resources and get a better life. That is really the challenges of all of us. So, in order to accomplish the pathway to sustainability, we have to realize that that's a global challenge. Carbon dioxide produced in Korea or in China or in the United States will not make any difference. It's a carbon dioxide will be stored in the atmosphere. But at the present time, we are facing the problem. The problem is we are still operated under nation-state-based operation. Like United Nations is a nation-state-based. So in the Rio Plus 20, before the meeting, there were lots of good suggestions. But if one country objects to it, we'll eliminate, and at the end, we'll come up with a document which is not as powerful as solution-oriented. And we have to go beyond that. I can tell you, or can make a prediction. You see, at the present time, we are spending trillions of dollars on defense. We try to protect ourselves from the enemy come from across the border. But as time goes on, then people will realize we are making our own enemy in terms of global warming, extreme weathers. So the one who are threatening us, destroying us, is ourselves, is our own making. And the only way to solve the problem is global collaboration. So next year, in 2015, there will be a COP21 meeting. If we come up with some global agreement to reduce the carbon dioxide, we still have chance to turn things around. But if not, then the future will be in danger. Of course, young people and older generation are very different. I think this is the first generation in the human society that you have the ability to interconnect it globally. I think our generation would not have the ability to do that. Now, the younger generation, through the smartphone, you can connect to everybody. And so you did see the sunflower movement in Taiwan, or student movement in Hong Kong, or earlier, Arab. There's a student movement and occupation of Wall Street, and all the young people now can communicate, can learn together. And if one day, if young people said, yes, in order to survive, we will work together and change the world. And that is certainly something could happen. I think in Taiwan there's interesting student movement earlier in the spring, really turn things around completely. And so I still hope that the older generation like me didn't do well enough, but the young generation will have a chance. Ewha University, mostly women students, I think can play a very important role. Well, the other thing is, I was saying that we, 300 years ago, we dissociate ourselves from sunshine, from nature. And if we want to really sustainably transform human society, we have to go back to nature, go back to sunshine. And it's interesting, if you look at the sunshine, which is so powerful, in 1 hour, sun will transmit the amount of energy to the surface of the earth. That amount is about the human society use in 1 year. We are not smart enough. So in the hot summer day, we are burning fossil fuel and try to drive the heat away and generating lots of greenhouse gases. But if we are smart enough, and certainly we are learning, we'll be using sunshine. We'll go back to sunshine. Sunshine is enough to keep us live beautifully. And so the process of so-called industrialization, take the farmland to become a concrete pavement and build the city, build the factory, producing, consuming, competing in the international market. That process probably will have to change. We really have to go back to sunshine. And that's something we are moving to. If you look at the price of a solar panel, which produce 1 watt of electricity, it costs $76.67 in 1977. Now, last year, 2013, is $0.74 per watt, down by a factor of 100. During the last 4 years in the United States, it went down by a factor of 4. It will keep on going down further. And many scientists predicted within 10 years, we could generate electricity cheaper through the solar panel than burning the fossil fuel, even the natural gas from fracking. It will be cheaper. So it means that the scientists and the engineers, they move to a stage that we can transform sunshine to electricity, but that's not enough. We have to learn to store the electricity or transform the electric energy into other form of energy, like splitting the water, make hydrogen to run through the fuel cell. So transform sunshine to electricity is moving along. Still, we have a challenge of how to store those energy, electric energy, so transport across the country. You can imagine, one day, if we learn to do it, then country like Australia, population density of 3 people per square kilometer, will be the richest country, just like Arabian country now. Arabian country has petroleum, but next you will have countries with enough sunshine will be the richest country. Earlier in the year, I visited Santa Barbara. One of my former students, Kim Prather, a brilliant female scientist, she looked at me and said, "Professor Lee, I installed solar panel on my roof. I satisfy my need of electricity, even my electric car." She bought a Nissan Leaf, and she said, "I'm now greenhouse gas negative. She said, so she looked at me and said, Professor Lee, can you do it? I said, wait a minute. In the United States, population density is only 30 per square kilometer. In Taiwan, we have 630 per square kilometer. We have only 1/20 of what you are getting. You have a big roof, big house. We live in an apartment. Everybody only have a small little roof, and we cannot do it. So when US said we can become sustainable, that's not enough. I think we have to make those energy store, transform to become a commodity, ship across the nation. Then there might be a solution. But that process is rather slow, development of science and technology. So we really need to change our lifestyle and things. So this is polar solar panel and wind. International Energy Agency is decarbonizing the energy system by 2050 will save the world by 71 trillion. And if you look at the wind power generation, wind is also coming from sun. Sunshine produces wind, and in many countries like Denmark, Portugal, Spain, a large fraction of electricity is generated by wind power generation. And United States, Japan, Korea are not among those countries. There are great potential, which one could look into it. But there are two other sources of energy which is not related to the sun, which is stored when the solar system was formed, and that is the geothermal energy. I know Korea is investing lots of money on this, and instead of using fossil fuel to boil the water to generate the steam and run the generator, you put the water, inject into the deep warm mantle area, and then that will become steam and run the electricity. Country like New Zealand and Iceland is moving on to distillation and depending more on the geothermal. The other one is the nuclear power. And lots of people are hoping that the nuclear power will be one of the options. But after Fukushima accident, where the people are now looking at the nuclear power in a very different light. One of the reasons is in the past 20 years, we didn't learn to manage the nuclear waste produced by the power generation. In the current nuclear power technology, we only burn 5% of the fuel, 95% will become the waste. Part of the reason is because of the proliferation of nuclear weapon. So we have to use the technology, which is not easy to make a nuclear weapon. So we use 5%, 95% become nuclear waste. And in Japanese case, after the earthquake, tsunami, ruined the emergency power generator and cannot pull out the core. And core not only melt down, it's melt through. At the present time, they did not solve the problem. So keep on producing waste. It's really quite dangerous. What Japan is doing is making the water level on the inland side lower than outside, so prevent the nuclear waste to flow into the ocean. Now they are also trying to build the refrigerator, big refrigerator using ice to contain the nuclear waste. But problem has not been solved. If you ask the question, why that happened? During the 60s and 70s, US was developing lots of nuclear power plants, and many of those are built in the Midwest. And you want to put the most important thing in the safest place. And in the Midwest, the biggest danger is coming from tornado. So you want to put the nuclear emergency power generator underground. So this nuclear power generator, emergency power generator, was underground. It's not in the Midwest, it's in Japan, and tsunami came and destroyed, and that's what happened. But after the earthquake, at that time, the vice president of ICSU, actually, it was already former vice president of ICSU, Rhoda Leko. When she saw me, she grabbed me and said, Professor Lee, tell me, how come the earthquake should happen only once in 1,000 years, happened this year? She could not find her mother in Sendai was missing, her mother was missing. So she was very excited and said, tell me, why earthquake which is supposed to happen only once in 1,000 years happened this year? Well, I said, I cannot answer that question, but if you were to live long enough, to live 10,000 years, then you will see in your place, you might find 10 earthquakes with a Richter scale as big as 8.5. So if you look at this and ask the question, during the last 50 years, how many earthquakes which is bigger than Richter scale 8.5 or a little less? There are 11 of them. Only one of them in Yunchuan inland. The other 10 are all in the ring of fire in this region, so-called ring of fire. So, if one of you will become the president of Asian Pacific Union, so big union, and if you were to live long enough, then you will tell everybody, don't build a nuclear power plant in this ring of fire, because earthquake is likely to happen every 10 years, actually every 5 years, with Richter scale bigger than 8.5. Where would that happen? Nobody can tell at the present time. Maybe in California, but not likely to be in Korea. Korea is a little away from the ring of fire. But Taiwan is certainly one of the likely place. So, as I said, that advance of technology allow us to replace the fossil fuel by sunshine. That come in in the next 50, 100 years. It will be slow. And so we really have to learn to live better for less. We have to learn better for less. We should not face in the financial crisis and keep said, consume, vitalize the market. And that's the wrong way. And if we keep on saying that we produce and consumer good and encourage individualized consumption, and one of the best things, iPhone 1, iPhone 2, 3, 4, 5, 6, and people try to replace iPhone. Well, now Samsung is more popular. I'm using Samsung Note 2. Now, I didn't replace the Note 4 yet. But individualized consumption is really not a good thing. One of my friends who used to be working on LED, very advanced company, stopped producing it. I said, why? I said, my LED, if somebody install it, next 20 years, he will not replace it. So I lose the market. So I want to move into something that the people keep on buying and using it. And that is just opposite to what we like to see. We really learn to use better for less and control population explosion. This is one of the things in summertime. I don't know. You will enjoy swimming in the soup of people. And as many people said, if population is not controlled, we've been big problem. As we said, 2050, it will be 9.5 billion people. Because of the climate change, extreme weather event, agricultural productivity is likely to go down, in spite of the fact people believe the GMO will help, but not help enough to make it up. So we are going to face great difficulties. And who to tell population should be controlled? If you look at the Sustainable Development Goal, United Nations is now setting up, didn't want to touch upon the population problem. Right? I didn't see anything touch upon the population yet. Do you remember? I think this is really important thing. And other thing is many of those things will not happen unless we improve equality around the world. You know, earlier this year, before I attend the Pontifical Academy of Sciences, Pope said he knew that the scientists are coming to Vatican and have a meeting. He said advancement of science and technology didn't help moving the bottom billion out of poverty, out of hunger, but created lots of billionaires instead. And he was quite disappointed by inequality in the human society, especially when science and technology develop, and when you have a system, winner takes all, and everyone want to become a winner, and if the investment of the capital is getting more than total expansion of the economy, the rich people are getting richer, poor people are getting poorer, and then a problem could not be solved. And that's something we really have to face. I think I am go beyond time. So this is one of the development we're seeing very often. And you see here, every floor is a swimming pool, a tennis court, and this next neighborhood is a tennis court. I like to play tennis, but I do not want to play tennis under this condition. It's a swimming pool. On the other side, it's really very deteriorated. And that's happening all over the world. All over the world. And the inequity also eroded into the democratic system. During the Pontifical Academy of Sciences, one of the attendees from Columbia University was saying that the US used to be a very democratic society, one man, one vote, that all the people in the free society tried to move into, but now America become $1, one vote. Because after the last change of the Constitution, many rich people conglomerate can control the media. Now in the United States, the number of people the fraction of people who do not believe in the evolution, who do not believe in the global warming, is now ranked #1 in the world. So this is something we really have to face. When the economy is expanding, you tend to forget that inequality is really important. But when the economy starts to stagnate, then there will be lots of protests, lots of social unrest. Well, I want to come back to the earth. Go down to earth. This is where we are staying. We are living here for a finite period. Maybe on the average 100 years, we'll give the earth to the next generation. My generation didn't do well. And we are not handing you the idealistic earth system for you to live, to prosper. But if you were to wake up and work together and move in the right direction, we still have time. But if you let it go 10 years later and try to change it, probably that will be a little bit too late. I'm not threatening you. As I said, I'm an old man, but I have to be honest with you. I could not see my granddaughter and tell her that your future will be bright, knowing very well if we do not do enough. My granddaughter, when she looked at my picture and said, Grandpa worked so hard, but he didn't work hard enough or effective enough to make this earth a different place for us to live on. When she is ready to say goodbye, she certainly will not forgive me that we have not done enough. So I hope you take up the challenge and try to face the problem. As I said, this is not one of the problems of nano-bio-environmental. This is the most important challenge we are facing today. You can give up everything. We have to have a sustainable earth for you to live on. Well, thank you very much for your attention.